What if you could step onto a spaceship tonight, fire up the engines, and by the time the sun rises tomorrow, you'd already be orbiting another star? Imagine leaving Earth, racing across the galaxy, and returning home before anyone even noticed you were gone. It sounds impossible, right? Because for as long as we've looked at the night sky, the biggest problem hasn't been the distance itself. It's the speed limit. Light, the fastest thing in the universe, takes over 4 years just to reach the nearest star. For us, that's an eternity. But what if we could cheat? What if we could move faster than light? Picture it. Stars blurring past your window, entire solar systems flashing by in moments. You wouldn't just explore the galaxy, you'd bend time itself. Because once you cross that boundary, reality starts playing by new rules. You might find yourself arriving at your destination before you even left. You might even catch a glimpse of the universe's most closely guarded secrets. And that raises the real question. If you had the power to go faster than light, would you use it to explore the stars? Or would you risk tearing apart the very fabric of reality? For more than a century, scientists have been telling us there's a hard speed limit in this universe. Nothing, not a rocket, not a particle, not even your wildest imagination of a spaceship can move faster than light. That beam of sunlight streaming through your window, it travels at nearly 300,000 kilometers every single second. And according to Einstein's theory of relativity, that's the ultimate cosmic speed limit. Why? Because the faster something with mass tries to go, the heavier it becomes. Push harder, burn more fuel, strap on bigger engines. It doesn't matter. As you approach the speed of light, the energy you need skyrockets toward infinity. Reaching that limit is like trying to run up a hill that gets steeper with every step, until it turns into a vertical wall that never ends. Think about it like this. If light is a Ferrari screaming down a highway at full throttle, we're riding bicycles on the shoulder no matter how hard we pedal. It's humbling, isn't it? The universe has drawn a line in the sand and said, this far, no further. And that's why traveling to even the closest stars feels hopeless. Alpha Centauri, the nearest one to us, is over 4 light years away. With today's technology, it would take tens of thousands of years to get there. That's longer than human civilization has even existed. But here's the thing. Rules exist to be tested. And the moment you start asking, what if we broke this speed limit? That's when things get very, very strange. So let's imagine just for a moment that the rules no longer apply. You fire up your engines, push past the speed of light, and suddenly the universe opens up in a way no human has ever experienced. The sun, which usually takes light 8 minutes to reach us, is now behind you in seconds. Jupiter, Saturn, Neptune, those giants you've only seen through telescopes, fly past in the blink of an eye. Keep going, and in just a few hours, you're arriving at Alpha Centauri, a journey that normally takes light more than 4 years. Instead of generations living and dying on a ship, you'd get there before dinner. Think about what that really means. Exploring other solar systems wouldn't be a dream for the far future. It would be as routine as booking a flight overseas. New worlds with strange skies and alien landscapes could be weekend trips. The galaxy, which has always looked impossibly vast, suddenly becomes a backyard. But here's where the excitement takes a turn. Because if you can break the light barrier, you're not just playing with distance, you're playing with time itself. What would it mean if you could reach your destination before you even left? What would it mean if moving too fast could let you glimpse tomorrow or erase yesterday? That's when the fantasy of faster-than-light travel turns into a whole new kind of problem. And the deeper you look, the stranger it gets. Here's where things start to get messy. Because as exciting as faster-than-light travel sounds, the universe doesn't exactly welcome it with open arms. In fact, it fights back in ways that are almost terrifying. The first problem is energy. According to Einstein's equations, the closer you get to the speed of light, the more energy you need to keep accelerating. And it's not a little bit more, it's exponential. Double your speed, and suddenly you need way more than double the energy. Push closer still, and the requirement shoots upward until it becomes infinite. Infinite energy. Think about that. You would need every ounce of power in the universe just to hit light speed, and somehow even more to go beyond. Our rockets, our fuel, even the brightest stars burning in the cosmos, None of it is enough. But let's pretend, just for the sake of curiosity, that somehow you could pay that impossible energy bill. The universe still has another trick waiting for you. Causality, the order of cause and effect, the very thing that makes sense of our lives, starts to unravel. If you could move faster than light, then signals, messages, even people could arrive before they left. Imagine watching a baseball fly across the field and it hits the glove before the pitcher even lets go of it. Imagine sending a text to your friend and they read it yesterday. This is where the paradoxes creep in. What happens if you go back in time and stop yourself from ever taking the trip in the first place? The famous grandfather paradox asks, what if you prevented your own existence? Do you vanish? Does the timeline rewrite itself? Or does the universe simply refuse to allow the contradiction, locking you out of those possibilities? And it's not just philosophical. Physics itself seems to break under these conditions. Some solutions to Einstein's equations actually allow closed time loops, paths through space-time where you end up right back where you started, not in space, but in time. A cosmic merry-go-round you can never step off. So the reality is this: faster than light travel isn't just about going faster. It's about ripping holes in the very fabric of cause and effect. It's about turning the universe into a place where yesterday and tomorrow blur, where events lose their natural order, and where logic itself starts to unravel. And yet, even with all these terrifying consequences, physicists still wonder, is there a loophole? A way to move faster than light without breaking the rules of energy and causality? A way to cheat the system without destroying it? That question leads us into some of the strangest and most mind-bending ideas science has ever dreamed up. All right, let's step through the looking glass. If traveling faster than light breaks the rules, what if we found a way to bend them instead? Physicists have been playing with this question for decades, and the answers sound like something out of science fiction. The first contender is the warp drive, not the kind you see in movies with glowing engines and streaking stars, but a real theoretical concept called the Alcubierre drive. The idea is surprisingly simple. You don't move faster than light yourself. Instead, you bend space around you. Imagine putting your ship in a bubble of space-time. In front of you, space contracts. Behind you, it expands. The bubble rides that wave, carrying you along, while inside it, you never actually break the speed limit. To an outside observer, though, it looks like you've traveled faster than light. Sounds perfect, right? Well, there's a catch. To power this bubble, you'd need a substance called negative energy. We've never seen enough of it to make anything close to a working engine, and it may not even exist in usable amounts. Then there are wormholes. Think of them as cosmic shortcuts, tunnels through space-time that connect two distant points in the universe. Go in one end near Earth and step out instantly near a star thousands of light years away. If they exist, they could make interstellar travel as quick as walking through a door. But keeping a wormhole stable requires the same kind of exotic matter as the warp drive. Negative energy again. Without it, the tunnel collapses in a blink. And here's something stranger: quantum tunneling. In the quantum world, particles sometimes leap through barriers instantly, as if they have cheated the laws of physics. It's a real phenomenon we've observed in experiments, and it happens faster than light would normally allow. But scaling that up to move a spaceship, or even a person, isn't something nature seems ready to permit. It's like trying to take the weirdest glitch in a video game and use it as your main mode of transportation. What all these ideas have in common is this: they don't ignore physics, they twist it. They suggest that maybe the universe has hidden back doors, ways to move across impossible distances without technically breaking the rules. And even if these concepts sound outlandish now, remember that flight, space travel, even splitting the atom all sounded impossible once too. So the question remains, are these loopholes genuine possibilities, or are they just dreams? Mathematical tricks that collapse when you try to build them. The universe may already have its answer built into its design. But here's the twist most people don't expect. The universe itself has already broken the light speed rule. Not with spaceships, not with lasers, but with space itself. Right after the Big Bang, the universe expanded faster than light. In a fraction of a second, everything ballooned outward at a speed so extreme that regions of space we see today were once impossibly far apart. And even now, in the farthest reaches of the cosmos, galaxies are drifting away from us faster than light. Not because they're moving through space, but because space itself is stretching between us. That's the loophole the universe seems to allow. You can't move through space faster than light, but space itself can expand and carry things along at superluminal speeds. It's like being stuck in a boat with a speed limit. You can only row so fast, but then the river's current picks up and sweeps you downstream faster than your oars could ever manage. Why would the universe give itself this exception but keep us locked out? Maybe it's a safeguard. If civilizations could hop across the galaxy in an instant, the fabric of time and causality might unravel. The laws of physics might exist not just to govern reality, but to protect it. It almost feels like the cosmos has hidden its treasures behind a glass wall. The stars are there, just out of reach, close enough to inspire us but far enough to remind us of our limits. The fact that only the universe itself gets to break the light barrier may be its way of saying, this rule isn't for you. And yet that hasn't stopped us from trying to find cracks in the wall. Because if space can expand faster than light, maybe, just maybe, there's a way for us to ride that same trick. If you enjoyed this video, please don't forget to subscribe. And if you want curious questions answered, have a look at some of our other videos.